Hello. Hello. Give me 1 sec. Good to see everybody. Sorry I'm late. 1 second. Apparently I have to re-sign into Zoom. I didn't see that coming. Give me 1 second. Sorry. Oh, yeah, of course. 1 second. Sorry. Oh my gosh. Huh. Okay, I have to. Yep, new password and everything. Okay, 1 second. This is not the day that I was hoping to have delays or expecting to have delays. Sorry, 1 sec. Okay, 1 sec. And I know someone's here in the waiting room. Give me 1 sec. Stupid way to start today. Um, hold on. Okay. Okay, people are here. Hold on, bear with me. I haven't even said hello. What a sad way to start the last. Okay. Okay, here we are, here we are, here we are. Okay, are we here? Are we here? Are we here? But can you hear me by the way? How would we know? Okay, 1 sec. Okay, now we are here. Okay. We can hear you. Thank you. Okay. Oh, and there's a lot in the chat. Okay. Okay. Here we go. Here we go. Sorry. Totally. Because I had to restart. Well, it doesn't matter what the reason is. Okay. We're going to, let me look at the, okay. Wait, wait, wait. Okay. Hold on. There's already questions. Wait, 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 wait. Okay. So first of all, good afternoon, Alexis. Good afternoon, Logan. Good afternoon, Katie. Good afternoon, Emily. Good afternoon, Stephanie. Good afternoon, Paulina. Good afternoon, Brandon. Good afternoon, Jada. Afternoon, Maria. Good afternoon, Claudia. Good afternoon, Victoria. Wow, everybody's here. This is awesome. Good afternoon, Jenna. Good afternoon, Shawnee. Thank you, Alan. Wait, you did not do that on Lab on Friday? Wait, you didn't? Wait. Wait a minute. All right. Good afternoon, Shirley. Good afternoon, Shy. Good afternoon, Alan. Wait, oh my God. And you didn't? Sorry, I should not be sounding like this. That is a surprise to me. You had to finish lab 6. Uh, okay. Well, I'm glad you're all right. That does throw. Okay, okay, okay. So here's the deal. Thank you for so I'm responding to there's things in the chat about that you didn't do a review in lab on Friday. It's in the public chat and it's also in the private chat. Okay. I'll admit right now I'm slightly thrown by that information. Like you're right to tell me that is not what I thought was going to happen Friday, and I'm surprised. I am surprised that I did not know that until right now. But oh, okay. Okay, so in other words, they were like trying and hoping to, but then they were okay, okay, I see. So it wasn't like a total miscommunication. It was like a something didn't work out kind of situation. It sounds like okay, okay. I'm glad you're telling me. All right, this does change. Okay. That does affect. What was lab? Just tell me very quickly. What was the lab 6 that you were finishing? We were told if we finish it. Okay. Okay, okay. All right. So there was like a slight, okay, fine, fine. All right. I'm not going to dwell on it. I totally appreciate you telling me. Just tell me quickly, first of all, it was Walters, right? I mean, just so I mean, not that I mean, it doesn't matter, but I mean, I am picturing the correct section, right? You have Walters on Friday. Yes. Yes. Okay. Okay. And lab 6 was the pendulum lab. Okay. Okay. Well, that is not what I expected to hear walking in here, but okay, then this is what we're going to do. Then this is what we're going to do. I mean, thank you. Okay. Then yes, I mean, I will adjust to this. I'm gonna have to move a little bit fast myself. All right, let me get a couple announcements out of the way. I mean, certainly what we were gonna do today was wrap up and put you in a position where you'd be as prepared as possible for the end and for 204. So now I'll just do it differently. That's all. We do. Oh, okay, okay. All right. So let me get, so please pay attention. So today's gonna then it'll be a little bit less fun than or something, but I don't think anybody's interested in fun as such right now. So let me get a couple announcements out of the way. And then what I'm gonna do, what I'll tell you right now, and I do hope that this keeps you here today and watch the video if you have an issue. What I'm gonna do is I'll do a fast walkthrough of I will get out the exam in like 5 minutes from now. I will get out the exam on my screen. I'll hope you'll have it on your screen, and I will walk through it as like giving you like my best understanding of how you should prepare for each question, and I'll give you I'll just walk through it. That doesn't mean I can give you. It doesn't mean I can give you like detailed answers right now exactly, but I will walk you through it, and I will also tell you, given this information, the other thing I will tell you once I get rolling with that. So, and when I do walkthroughs, and especially if I go fast and then you rewatch the video later, I mean, they're often even more better for some people than any written set of solutions anyway. Whatever, I'm not gonna. So that's what I'll do. In 2 minutes, I will walk you through the practice exam, which again was not exactly what I was intending to do today, but that's okay. What that also means is I will tell you in advance that since we're going to do it like this, remember your actual exam will be posted no later than 8 p.m. tomorrow night, which means it will be posted tomorrow evening, like whatever. It'll be, and then it's due back, whatever it says in Google Classroom that it's due back. I mean, I think that's this Friday, but just check. I'll tell you right now that your actual exam will not depart heavily from whatever we walk through right now. Okay, that's like the best I can like offer you in acknowledgement of the fact that you are reviewing with me right now rather than last Friday. Okay, so whatever I walk through in a minute or starting in a minute or two, like is directly applicable to. So don't think of it as I'm walking through your practice exam. I'm walking through your exam. Okay. I mean, that's what I'm trying to say. All right. I think you understand. I mean, and I'm going to ask you too, once I get rolling, because I'm going to go fast, I'm going to ask you to sort of just keep like giving me like little thumbs up or just little peppers in the chat or with hand signals just to be like, yes, we're still with you. Yes, we're still with you. Okay. I mean, wait, hold on. It's due whenever we said, hold on, guys, wait a sec. I think didn't we already? Hold on. I'm seeing in the, what did I? Oh, it says, okay, what it says in the chat, and I think this is fair. I mean, not in the chat. What it says in your Google Classroom, and I think that thought was put into this. It says that it's due back 11:59 p.m. Saturday night, December 17th. So you have all of Saturday to do it. It's not due Sunday, but it's due midnight Saturday. If that's a real issue for a lot of people because of conflicts with other, I'll think about whether I could change that to Sunday. I will, because I just saw something in the direct chat. Like maybe while I'm talking, you guys can pepper me in the direct chat. If that's like a real thing across the board that Sunday would make a big difference over Saturday, I'll consider it. I'm just a little worried about making major changes at this point and throwing people off and throwing off your other, but I hear you. But right now it says that it's due midnight Saturday. If you want during this class to send me more thoughts on that, I'll take them seriously. I hope you see I'm taking all of this seriously, but I can't promise any changes.
Question?
Yeah. Wait.
Question. Katie. It's Katie. The 17th is Sunday.
Right. Wait. Therefore, oh, you're saying, oh, so I said, oh, the 7th. Okay. Okay. I see what you're saying. All right. Well, you know what? Okay, then fine. Okay. That's helpful. Wait. Oh, someone's saying sorry. Uh, okay. You know what? If that's the case, then I apologize. That's good enough for me. Just the mere fact that there's an inconsistency in the thing, that's already confusing enough. That means I have to make a change anyway. Fine. I'm going to try. I don't mean fine like in a rude way. That's helpful. Right now, in front of you, and sorry to sound frantic. I know we're all a little bit frantic at this time. I'm going to change it right now to 11:59 p.m. Sunday, December 17th, since for just because of what Katie just said, because if I already had a typo in there, that already makes it confusing, but might as well. All right, so I'm changing it right now. I would like to see, and I'm changing it for the other class too. Hold on a second. And I can't see the chat right now because I'm doing it literally right now, but I would love to get confirmation in the chat when I come right back that that's okay and that we're good and we can move. Because again, and again, I'm only frantic because, like, because the clock is about to run out. So I want to make sure everything is cool with everybody. I always end up sounding more stressy than I want on the last day. I'm not here to stress you out more. I'm stressed because I want to reduce your stress. Honestly, yeah, like you, meaning Katie, you meaning anybody, meaning whoever's in the direct chat about this. So I'm changing it right now. Hold on. Or I'm trying to change it right now. Hold on. In fact, while I'm changing it for both classes, if someone in the chat, if someone could check that, the thing in Google Classroom where it actually gives the, oh, that's wrong, where it actually gives the practice document for the final exam, that's the place where it says where the actual thing will be due. Like that's the announcement. Okay. If someone, I'm changing it right now. If someone could check, and I'm moving it, and I'll move the whole thing up. If someone could check that that it's there and it's official and it's clear and it's okay, then I'll move on in a second and I'll do a walkthrough of it for whatever that's worth. I mean, I think it will be worth something. Wait, so I want confirmation in a second. I'm trying to change the book. All right. I got to admit, folks, I'm laughing because I also had this like weird fantasy that I knew was not going to come true. I had this weird fantasy of covering what I wanted to do today and letting you go a little bit early on the last day, and I shouldn't even say that, but I don't think that's going to happen now. I mean, and I hope you understand. But I'm not here to give you more to deal with. I'm here to try to simplify that which you do have to deal with. All right. So in a sec, I'm just moving this up. So oh, for heaven's sake, that's not what I meant to do. Hold on. In a second, you're going to well, maybe you already did. And I appreciate if you did. Okay. 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 Okay, it should be now. I'm going to check. I think it's corrected. I think it's clear, and I think this should work for you. I'm hoping I'm going to check the chat now and see if we're okay. Wait, it scares me that there's nothing in the chat. How could there be nothing in the chat? Wait, so could someone confirm? Oh, no, there's no. Yeah, yes, okay. Thank you, Shot. Yes, thank you, Alexis. Okay, great. Okay, wait. It doesn't show anything? Wait, I think, all right, Shawnee, I think that, I mean, I think you should check again because it looks like it looks okay to the other people. Okay, all good. Thank you. Okay. I'm looking at the chat. All right, so I'm assuming that I did that. Okay, it changed. Okay. Well, refresh, hit refresh, Shawnee. And the that you're on, I mean, I'm going to move on a second because I don't want to be rude to you, Shawnee, or to anybody individually. But if it's corrected on most people, I'm going to assume that like there's something on wait. Well, if you go to classwork and there's nothing there, that's something on your end. Okay, maybe we should talk privately right at the end of class because like there's definitely if there's nothing there, then okay, well, if there's nothing there, I don't know. I can't actually, at the risk of being rude, I can't, that's something on your end because there's definitely stuff in classwork. So I think that's something you'll need to work on. And if you want to hang out for a minute after class, I can try to help you. And I mean that in the most like because it looks like it's okay.
It's just all of a sudden it's not there. When I first logged in, everything was there like it normally is.
Okay.
And when I went to classwork, it just shows me a loading page and that's it.
Okay, so, but that's, and I feel bad about that, but that's something on your, we could, why don't you hang out for a second after class? Like, that's something that's going on your end that maybe we can look at together, but I can't actually, I think we want to get I think you're going to want to hear this walkthrough of the exam as much as
But
anybody
it's
else.
not showing me anything to click to
Shawnee.
even see the exam.
Okay, but I can't, well, but that's something on your end. I can't hold up the whole class. I mean, I do feel bad, but I think you maybe just, and also remember, this will be a video that you'll be able to see later. So my best suggestion to you is you just like take notes for the moment. Just try to absorb what I say about the walkthrough. And maybe also if you hit refresh or if you turn or something, it'll come back in the middle. But if you just take fresh notes on what I do on the walkthrough, then it all makes sense when you watch the video. I don't know. I don't know. I mean, yeah, and I feel we could talk right after class. Okay. What was I just, okay, but we're good on the other thing. Okay. Let's change. Okay. So I'm going to, and again, to everybody, I mean, this is I just think I'm going to just try to favor whatever's like the best for the whole group at the moment. And I mean it to everybody. Is this the exam where the extra points will be considered to? Okay, wait, I'm going to quickly answer this. Someone's asking in direct chat, like, is this the exam where the extra points will be considered too, like the points from the Google Classroom games and everything? Okay, any of you, I think, is gonna want to rewatch the video from either the last class or like the very first couple of days of class where I explain the whole grading system. Let me assure you that the extra points, the huge, they're not even the many points that all of you have acquired through all the homework and the participation, all that goes on your final average. It doesn't just even get added to an exam. It gets added, it gets included in your final average. Like it means a lot more than maybe you even realize if you're asking that question. So the quick answer to someone in the chat who's asking, is this the exam where the extra points will be considered, is, well, the quick answer is no, the extra points are not even just going to an exam. They're going to your whole grade, which means they help you more than I think you think. So that's a quick answer. Okay. So, the other questions and yes, and again, I'll calm down in a second. I apologize if I'm being rude to anybody. That is not my intention. But I'm just trying to tie these loose ends together for the end of the semester. So also when someone asks, what's the final day to turn in homework? Well, that is today, because today is the last day of classes. So I'll take them till midnight. And I think I said this in that. And so you guys might, all of you, and I mean this, you may want to rewatch the last couple of videos and or the first couple of videos of the semester if you're like concerned about grades and stuff like that. Like, but yeah, I will take some old homeworks by midnight tonight. I will, but I can't really take them tomorrow because then we're into finals and it'll also just make it, I can't, but I can take them till midnight tonight. That's number one. Number two, remember, please also know that I still owe you guys a lot of points. You're still getting more points than you even know. You'll eventually, before you get your final, you'll eventually get a grading sheet. To all of you will get a grading sheet that shows all the numbers and shows exactly how your final grade got computed. It'll be later than you want, but you'll get it. It'll make everything clear. And it also, how can I say this? I have to say this quick. Okay, here we're into the realm of the announcements that I was going to make today. Anyway, I think I already explained how I'm going to favor your better exam over your worse exam. If I didn't explain that at all, let me know in the chat. But if you heard me explain that at all last time, maybe put an indication in the chat and then everybody else can rewatch the video from last class to get assurance that, believe me, I have your back, all of you. I mean, we're here to do well. If there's any chance that you have done anything good that could help you do well in the class, I'm here to help whatever good things you did blossom into the best possible result for you possible. You got to give me something to work with, but if you did or do, then I will work with that. The system is designed. The system is designed to be fair and transparent and equitable. Like the system doesn't treat any one person any different from any other person, but the system allows, the grading system of this class allows more than one possible path to a high grade. Like some people will get a high grade because they did really well on exams, even though they never did any homework or like they never came to class or whatever, or they did badly in labs, but they did really well on exams, as it turns out, even if they didn't know that at the time, and they'll get a high grade. Other people who will have done really poorly on exams, but did tons and tons of homework and tons of participation in Rock Lab, they will do well too. Like I'm going to move along in a second, but I just want you to remember and know the grading system is designed to take whatever you do best and give that the most weight in the grading system. That's the point. It is not, it's designed to not treat any one person with any different rules than any other person. The rules are the same, but the rules are, the math rules are meant to promote as much good work as possible into as many good grades as possible, like that. And if you want more details on all of that, please watch the old videos. But that's like my assurance, as stressy as I sound right now, that I want you to understand that when you go in to take the final, like you're trying to do well so that our grading system can shine your wellness even brighter. Okay. So all those points do matter for something. Another, So two other quick things about the grading or about like loose ends. So yes, I'll take homework still tonight. You'll still get more points. There's still more points that I owe you that you'll see in the end of the day. Go in to the grading sheet that you'll get that will explain how you got your grade. If it ends up that you get a grade on CUNY first, that you really, even after seeing the grading system, the sheet, which you'll get in time, even after seeing the whole grading sheet, if you really think something is literally self-inconsistent or mistaken, i.e. unfair, about your final grade in CUNY first, you'll reach out to me politely and generously. And if there's actually a mistake, I'll be just as happy to find it as you. And if it results that I have to change your grade to something higher, believe me, I'm just as happy for that as you. So it's not, there won't have to be any fight or anything if there's truly a mistake. But first you'll look at the grading sheet that you'll get, and you'll see if there actually was a mistake or something missing or something like that. And then you'll politely reach out. And now look, this doesn't end up really happening that often, but like it usually works out that people see the grades and see how it was done and see that it was okay. But if there's an issue, I'll be happy to fix it. And I can submit a grade change form. I've certainly done that before. It's not drama and it doesn't need to be drama. But the other thing, just to get out, so I'm in the realm now of the speeches that I usually give on the last day. Okay, like I'm coming back here to what you. But the other thing that you should just know. Wait, I'm just looking at the chat. Wait. Yeah. Oh, great. I did say something. Okay. Cool. All right. Thank you for the chat. Great. So if I said that, if you want more details of that, you can rewatch the videos. But yes, what Maria just put in the chat and Alexis put in the chat, like. Yes, that is true. I'm good. Other thing I'm going to say quickly now that I say, and again, I really hope to see you guys in 204. I mean, first of all, I hope you take 204. I think you kind of have to, but I hope you feel ready and excited to take 204, and I hope to see you there. And I hope that this is all just sort of a pause in our relationship together. And I hope you come back, we have holidays and you are satisfied with your work and satisfied with your grade and come back ready to do more. That's the hope for everybody. I will say the grading system is designed to be generous and not generous. Well, yeah, it's designed to be compassionate, and it's designed to make you not competitive with one another and not competitive with me. Like that's the hope, is that we're all working together to get as many high grades as possible. And usually that works out like that. Now, of course, there are some people that don't, like, it also works because there's always some people that don't do anything, or for whatever reasons, like family reasons or whatever, and don't do even enough to pass the course. There are always those people, and there are always those situations, and some people retake the course, and there is no shame or indignity and anything like that. Let me quickly say, if I end up seeing you for whatever reason in this course again as a 203 student, it'll be a fresh opportunity for both of us to start again and to make sure that we both together nail it the second time. Like, and I mean that honestly for any of you that, because I usually do every semester, I'll see another person or two again. And there's no shame and there shouldn't be any defensiveness, or what it is just a financial heart. I mean, you've already been punished because you have to pay twice for the same thing. That's enough punishment as it is. So anybody, if you end up showing up here again, I'll greet you with open arms and I'll consider it my duty to work even harder to make sure that you don't have to see me a third time, honestly. So please note that in advance. There is, and I've done things twice, believe me, I've had to do certain things twice in my life. And there should, honestly, if we all had more time and more money, we'd all do all of this many more times than once. No one really can learn this the first time anyway. So, okay, now that said, I'm also going to quickly say, and I know I'm saying a lot, but and I'm trying to like calm myself down in a way, but I also want to say, if on the last night when once you do this exam, I'm going to be dealing with grading for like a lot of students and a lot of grades, and there's a rigid deadline for getting into grades, and it's pressure for everybody that you're under and we're under. So once I'm deep into grading, I can't like devote a disproportionate amount of attention to any one student because I have to get them all in, blah, 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 blah. Now here's the part you do need to hear or may want to hear. If on the very last night when I'm submitting all my grades to CUNY first, and you still, maybe then you might still be waiting for your grading sheet that tells you what's going on. It may be that last minute. But if at that moment, if I find out that one of you is suddenly about to get a D or an F, and I didn't know that before, and you didn't know that before, then you don't want that. I know that. No one wants to be surprised on CUNY first by an unexpected D or an F. Believe me, I understand that. So I'm telling you right now, and I hope you all hear this, in the small case scenario that I learned at the very last minute, that if I were to just submit a grade for you right now, it would be a D or an F, I won't do that. What I'll submit is an incomplete, which I'm not supposed to do, but that's what I do. And so I want you to know right now that if you see an incomplete on your transcript, first of all, I hope you all understand, incomplete is meant for like medical reasons and stuff like that, but it literally means incomplete. It means that something else has to happen, and then something between the student and the professor has to happen. And then once it happens, like an exam that needs to be taken, then the professor will then submit an actual grade with a form, and then the grade will be changed from incomplete to the actual grade, and the incomplete will vanish, and it'll be like it never happened. It is not in any way a blemish on your transcript. It's a total holding place. It's a holding position for waiting for an actual grade. It's meant for medical emergencies. I use it to say, wait a minute, at this last moment, I have incomplete knowledge of the situation. Something is incomplete here, like they never adequately did the midterm or the exam, and I didn't know that until now, and I didn't give them enough time to deal with that fact, whatever. So if you get an incomplete, please don't be angry. Please don't be freaked. Don't have a heart, don't check yourself into a hospital. If you get an incomplete on your transcript, it means politely reach out to me by email or text and say, okay, I got an incomplete. Can we have a phone call or a meeting? And what are our next steps? And I will meet you with equanimity, and I'll say, right, okay, so here's the deal. Like, if I hadn't given you both your exams actually turned out to be like kind of problematic. So I'm going to give you a chance to redo something here, and we're going to make this right so that you're not caught off. Okay, so basically, if you get an incomplete, reach out to me, and it's an opportunity for us to fix something that needs to be fixed. It happens like once a semester or something with one. Okay. If you don't ever reach out, then I know, okay, they've been AWOL the whole time and they're still AWOL. And if you never reach out and the incomplete just sits for a number of weeks, then it does turn into a WU. So it's an opportunity, okay, for me to take responsibility that, all right, something is missing here and I don't know if it's the student or me. So let's make this right. Okay. So wait, okay, so quickly, just somebody put in the chat if you heard, and you can replay that slower on the video, but you get what so basically I'm saying, I mean, C- or higher, like hopefully there aren't a lot of C- or Cs, but okay, great, thank you. Okay, great. So, I mean, is it possible to end up with a C- or C in this course? Yeah, it's possible. I hope you don't. I'm working for you not to, right? But some of you know, if you've never done any work for the course, blah, blah, blah. Hopefully you're not going to get a C- or a C, but I mean, if you do, you do. And then you'll look at the grading sheet and see why that happened and let it sink in. And anyway, you get all of this. Okay. But if it's going to be lower than that, you'll have a chance. If I haven't already reached out to you already, that is. I mean, in some cases I have. Okay. All right. So that's that. Last other thing. this is last minute too. I might have mentioned this last class. If you get something that looks like it came from Blackboard, if you get something that's like a survey from Blackboard, please don't throw it away. Please do it. It's super important. It will really help your future in the department. I'm endorsing it. It's indirectly coming from me. It's just that I don't use Blackboard, so it'll come through a weird. But if you get a survey in the next week through Blackboard that has anything to do with physics or comes from me or a lab, please do it. And I should say this, I won't see your results. It's not about me, don't worry. And it's not about you. It's like a survey about whether you're heard in this science department or not. Just please do the survey and I'll never see your results, I promise, but I will see whether you did it. And I will give extra points for anybody who did it. I will. That will also be added to, like, it's like a game, okay? I don't know exactly how many points, but I will give a substantial number of points if you do it. So just look out for that. Okay, cool. All right. Oh, you heard. Okay, great. Okay, so that's all of that. And again, I will calm down once I'm talking about physics. But again, the bottom line is like, well, I think you get the bottom line. All right. Okay, so what I'm going to do now is I'll turn to the practice exam. I'll turn to and it'll be on the screen. So even if it's not working on your end on Google Classroom right now, you'll see it on the screen. I'm going to switch screens. And like I say, I'm just going to blast through it. We have one there. Okay. Oh, well, let me pause for a second. Are there any other, this would be the moment. Any other, like today I was going to tie up physics loose ends, but I'll do that through the practice exam. Are there any other questions or like issues or things about tying up the semester? I'm looking in the chat. Is everything, or just raise your hand if you're good for me to like go now deal with the practice exam, or raise your electronic. Okay. Thank you, Claudia. Thank you, Maria. Okay. Thank you, Katie. Okay. And thank you, Emily. Okay. That's good. And thank you, Shai. All right. Thank you. Okay. So that's what I'm going to do. All right. And I'll take a breath here. I'm just going to it. And again, yes, your thing will be very similar to this, maybe not exact, but okay. And while I'm taking a breath and pulling it up, you have been an amazing class, seriously. And I will miss having you. I'm not kidding. I hope to see you in 204. I'll be doing 2 out of the 3 sections. Mercedes will be doing 1 of them. So I hope to see you, but either way, I hope to stay in touch and happily write recommendations or support your future. You have my email and my text. It won't change. Okay. I'm getting this now. Okay. And and again, I'm deliberately sort of slowing myself down because I think this time of the year is unfortunately stressful for everybody. Again, and it affects me. I don't like it either. But I don't mean to make it worse for you, but I guess I keep saying that. So, all right. So here we go. I'm going to switch the screen. Okay. We'll be back. Okay. I'm switching the screen. I'm trying to switch. All right. Now this is going to be a walkthrough. Like I'm not even going to write anything down. I'm going to talk. You write whatever down that you think is valuable. All right. So this is the exam. I'm not going to swear by exactly the point values, but that's that's the idea. You should assume that all the questions are basically worth the same points. Oh, and also let me say about this exam, I'm scrolling through now you should assume, like if it asks you for a specific diagram, like a free body diagram, whatever, like do what it's asking. Anytime it's asking you to do a calculation, you should assume that the first time, even though the questions are sort of short, they're like all meant to like guide you somewhere, and they are all meant to kind of take you down a thought process. If you get a calculation question, if it's asking you anything that requires any thought, the first time you get that type of question, you should do the 5-step method. Like we are still looking for that here. You should make an effort on your document to make clear to me that you have assimilated the 5-step method. Like we still use it in physics 204, believe me. So anytime something's asking something sort of like for the first time, you should do the 5-step method. If it's asking for a diagram, like, no, it's just asking for a diagram. Okay. But if it's asking for a solution, do the 5-step method. Then if it starts, once the questions get repetitive, like if it asks you for the same thing again there, or like 2 pages later, you can always say like see above or something. You don't have to keep doing, but show me, go top heavy on the exam, go a little crazy at the beginning to really show me that you're in it to win it. And then you can get more streamlined as you go. I will also say, okay, I'm literally going through this. Here's the cover sheet. There will be a cover sheet for yours. Will be a different picture. I seem not to have given you an equation sheet here in this document. But it is open, and I'll try to remember to put an equation sheet in the document, or at least, or upload one. But it is open source exam anyway, so you are allowed to use any equation that you have written down from your notes and stuff like that. Just remember your job at all times in this exam. Your biggest job is to produce a document that stands alone. Like all the way while you're writing everything down, what you should always be asking yourself is, could I follow this even if I weren't looking at the questions at the same time? Like that really is the standard. Are you making sense to me and making everything clear so that all I have to read is your work and it is independently solving physics problems, right? Like that. And that's both an intellectual standard and a practical standard, if like I'm ever going to fairly and adequately grade all these things. Like give me a document that stands on its own 2 feet, like, okay, as you go through. So over present things at the beginning, over explain things, and please put the pages in order and all that kind of stuff. But okay. So we get to part 0, the setup. Okay, so all of this, so hopefully you're with me. And again, just send me little shout outs in the chat if like you're still with me or whatever, but I'm on page 2, the first page of what's going on in this exam. Now, this is literally part 0, the setup. It's literally giving you like the whole facts of what's going to happen. So you're not expected to do anything on this page with this page. And of course, by the way, just like always, everything you're doing on separate blank pages and then scanning in, as I think you all know at this point. But you're not, it's setting up. So you're going to start drawing a diagram, a picture of all this on a separate page, and that'll be your step 1 DFP. It's an inclined plane, like we talked about in lab and all of that. It's a frictionless inclined plane. So what's going to happen here? It's going to add this whole point of this whole set. So it's an inclined plane and there's no numbers. You're just supposed to assume that the angle of inclination, the angle from the horizontal, is theta. You're supposed to assume that you got some mass you can call it m, and the acceleration due to gravity is just that letter g. All right, so there's no numbers yet. Okay, you can call the mass on the inclined plane m, even though it doesn't tell you that. You certainly can. The fact that it doesn't even tell you a mass is a strong indication that when you start doing your work and getting answers, probably for most of your answers, m is going to cancel out of any equations you do. So you certainly don't want an m in any final answer, but you can call the mass on the plane m if you want, if it makes it easier for you to like analyze things while you're going. You can always do that. All right. Again, you could stop me too. Oh, there is something in the chat. Sorry. Oh, sorry. But here. Okay, cool. All right, awesome. Excellent. Okay. So you draw an inclined plane of where the theta is measured between the plane and the horizontal. Okay. So now what it's going to do, it's going to do part 1, and part 2 is going to ask you a bunch of questions and the overview of what's happening in this exam. Like this is all, it's sort of focused on something that we made a big point of in a couple of particular days of class. It's going to ask you to ultimately to derive the acceleration of the block down the inclined plane. The purpose of this big part of the exam is it's going to ask you to derive A as a function of g and theta. You're going to get an answer for A, but it's not going to be a numerical answer. It's going to be an expression with a g in it and a theta in it. And ultimately, and I'll tell you in a second what the answer is that you're going to try to get. But what you want to understand is whatever answer you're going to get is going to be the same answer for all of by the time you get to the end of part 1, and by the time and I'll scroll back in a second, but Part one and part two are trying to guide you through a whole thing to show you that no matter which way you do this, you'll get the same answer. And I'll tell you right now what the ultimate answer should be, since there's no friction yet. The ultimate answer to the end of part one and the end of part two should be A equals G times sine of theta, right? And again, you can watch old videos to like walk through all of this, but we're trying to show that the acceleration down an inclined plane is G sine theta, whichever system we use. And part of the reason we're doing this is because to be able to do this like sums up like a lot of things, concepts from the course. I hope that's clear. Like forces, accelerations, Galileo's principle of relativity, like the vectors, like it's all anyway. So the ultimate thing you're going to try to do in part one and part two is you're going to try to do things differently in order to land on the same answer at the end. The answer either way should be A equals G sine theta. I'm still going to keep walking through, but you also, if you know what's going on the big picture of all this, you should find that your work for, okay, well, I'll just start walking through it. So part one, we're doing the lab coordinate system. So we're intentionally telling you, choose to make x-axis like parallel with the floor and choose to make the y-axis perpendicular to the floor. Okay. And we're going to go with and then we're going to analyze from that perspective. So first, and stop me if I'm like all over the place, but first it asks, okay, it says acceleration. It says draw system schema. Well, I'll tell you right now. I think the system schema, like you'll draw a dotted circle for the mass itself, like, and you'll label it M. Like the dotted circle is the object of interest, the mass. There's only two other objects in your system schema. The two other objects will be solid circles, one for planet Earth or center of Earth, or what we call planet Earth or center of Earth or whole Earth, entire Earth, right? That'll be a solid circle somewhere in your system schema. And because that's always there, and there'll be a solid circle for the plane, because the plane is the only thing touching the mass. So it's the only other thing exerting a force besides planet Earth, which is always there. So you'll have a solid circle for Earth, you'll have a solid circle for plane. Each one of those objects will be connected to your dotted circle with one line representing the force of interaction. I'll tell you right now too, with the plane, if you've really been paying attention in class and really understand how these system schemas work, you might be tempted to put two lines connecting your plane to the mass, and that would strictly speaking be correct. Like that would strictly speaking show that you've been paying attention because you got a surface pushing perpendicularly against another surface. However, we're told here that the plane is not rough. We're told that it's smooth. We're told that friction is not going to play a role in this part of the exam. So you don't need to put two lines there. And in fact, my recommendation is that you don't, because it'll start throwing you off. You take that as you will. As long as you are consistent and explain what you're doing, I'm probably not going to take off points either way. But anyway, so you got a system schema here that I think has a total of 3 circles in it and a total of 2 lines. I will tell you right now also, this system schema that you just drew, and again, I'm going to go faster and faster. I'm watching the clock. I'm like assuming you already know a lot of the stuff. I'm just sort of reviewing it now. But I will tell you that system schema, that is true regardless of what coordinate system you're in. Like that's just what's going on, period. Then you're going to draw a pure free body diagram next. Same deal. Whatever you draw for this is just what it is. This answer should not change from part 1 to part 2. It's what forces are acting on the mass, period. So you take them from the system schema. There's 2 lines in the system schema. You're going to have a free body diagram that has 2 arrows in it. One is pointing straight down for mg. The other is now pointing perpendicular to the plane. You know, like my plane is going from down left to up right. Assuming your picture looks like that, then the normal force has to be consistent with that, perpendicular with that. So from down right to up left. So you'll have 2 forces in your free body diagram, an mg and a normal force. They should be labeled as such. I don't believe that they should be. I don't believe they should be equal in length. I'll let you think about which one should be longer. You could think about that, but I don't think they should be equal in length. So you'll have a system schema that has 2 lines in it, then you have a free body diagram that has 2 arrows in it. The arrows are what they are, period. But now, okay. And so we're still in a zone where our coordinate system choice has not become relevant. I'm watching the time. Okay. So then it says 3, explicitly specify every Newton's third law action reaction pair. Okay. I'm going to say this quickly. I'll probably say the answer once if you're listening, but the key thing about this is there's 2 forces in your FBD. There are 2 forces. That means there's 2 actions, so to speak, right? The key thing here is that every action in a free body diagram implies a reaction in some other diagram in the world that we haven't drawn yet, right? In other words, those 2 arrows are not a pair. Each one of those arrows is half of a pair, like always. So, so we're going to so I guess I'm just going to say that, well, you can replay the video a million times, so I don't want to dwell on this, but I'll say one of them, say that the MG arrow, that represents an interaction between Earth and the object. So the way I would phrase that as a Newton's third law pair is I would say something like, well, I would say this, the Earth. Let me back up for a second. I would either say the center of Earth or the entire Earth or planet Earth, like as opposed to dirt, as opposed to the ground or the floor or something. So I would say the center of Earth pulls down on the mass, like semicolon. Therefore, the mass pulls up on the center of Earth. That is a pair. That is one of the 2 pairs you would write down. That is the pair that embodies the meaning of gravity, of mg. The Earth pulls down on the block, therefore the block pulls up on the Earth. That's one of the 2 pairs. The other one I'll leave to you, but it's whatever that normal force arrow implies. Please just notice this, in what I just said, in my pair, there was no word gravity in my description. It was all about objects interacting with objects. It's like the actual Earth is pulling on the actual block. That's a force. And the block is therefore pulling up on the Earth. That's a force. The name for that whole force is gravity. But you don't say something like gravity is pulling down on the block, because then what would you say is the reaction? The block is pulling up on gravity. You can't pull on a pull, right? So make sure that you're phrasing it like object pulls or push object, and you'll do the same thing that I just did with the normal force. Okay, so that's that. That's that one. All right, now, obviously I'm going to, I'm giving you a lot. I mean, hopefully if you're paying attention, like I'm making this, hopefully this is like making your life very comfortable. I'm not going to do this with every single question, but I'll do it till I run out of time, I guess. So now it says use the coordinate axes specified above, draw a component free body diagram of the mass. Okay, so this is now, the key point is this is where the axes really come into play. Up until now, every question I just answered, it didn't matter what perspective I was looking through. It was just all true. So all those 3 answers that I just gave would carry over to the other part of the exam. But here, now, we want to we have to draw a component diagram. We have to have all components of forces lying along our chosen axes. And for this part of the exam, we've chosen these axes. So, so that means in this part of the exam, the thing that's going to be broken up. Now, again, I don't want to give away too much, but I guess I do, sort of. The thing that's going to be broken up here is the normal force, right? Because it's not lying along a horizontal or a vertical axis. So the normal force is going to be broken up. And it's going to and if the normal force is pushing up and to the right, so you want to zoom in. You want to zoom in well, okay, let me back up for a second. What I really recommend here, again, if you're really trying to show me that you really know what's going on and you want to rock this exam, I would draw first a preliminary diagram where you just literally zoom in on the normal force itself. Like make that the hypotenuse of its own right triangle and show with arrow, tips and tails are crucial for all these component things. If you have an upright arrow, show that it is the sum of right with a tip at the end, and then from the tip at the end of that rightward pointing arrow, start the tail of an upward pointing arrow. If that makes sense. So you have right and up makes upright, right? And theta, you know, and theta, well, and then you have to label one of those angles as a right angle necessarily, but one of those angles is theta. To cut to the chase right now, if you zoom in on the normal force by itself, I will tell you now, but you're going to need to explain this and show this in your exam. I will tell you right now that if you're paying, that when you zoom in on the normal vector, like the theta in that triangle won't be measured from the horizontal. It will be measured from the vertical. Now that's a really subtle point. And it'll separate the wheat from the chaff in this exam. Not just who does it, because you can listen to the video, but who does it with explanation. Like the theta that is given in this whole problem is the angle between the plane and the horizontal. The normal is perpendicular to the plane. So the angle that the normal makes with the horizontal is not the same as the angle that the plane makes with the horizontal. I just let that sink in and or play the video 400 times. But the angle that's given in the problem of theta is not, if you then zoom in on the normal force and make a triangle out of it and look at the angle between the normal, like the hypotenuse that you just made, and the horizontal of that triangle, that can't be the same theta as the one that's given in the problem. In fact, it must be the complement of that theta. And you've got to think that through, and you've got to be able to explain this in the exam. This, again, it's a kind of thing my eyes are going to go straight to the exam to see who actually knows what's going on, who's actually thinking and following and making sense of this, and who's just like copying video knowledge. So it's not, it's complementary to the original theta. Therefore, the theta that was given in the original problem is actually the angle between the vertical in your normal triangle and in the normal itself. And therefore, you will find, and I'm going to move along in a second, you will find that if you zoom in on the normal and you label its legs of that right triangle, you'll find that the horizontal leg is actually n sine theta, and the vertical leg is n cosine theta. Now, again, there's a whole video on this from like weeks ago that you can or should watch again, but it's the case. So now you go to, and again, I won't just accept you just like saying that, like you do want to show me why that is. So I would recommend first a zoom in diagram, then provide me with the component diagram where you'll have mg pointing down and you'll have some component of n pointing up and some component of n pointing to the left, right? And I'm telling you right now that you're going to explain to me why the component pointing to the left is actually n sine theta. It's not n cosine. And the one pointing up is n cosine. And I'm going to move on. But again, the fact that I'm saying that over and over means when you go to study or prepare this, like, yes, I know that's surprising. Like, I know that doesn't seem like it makes sense at first. So if you bump on that, you don't get all, like, you're in the right place if you bump on that at first. But I'm also telling you that if you really think it through, it's part of the issue that we're like on purpose looking at. So anyway, that's your component free body diagram. Okay. And then it says, so it'll have a total of 3 arrows in it, a total of 3 arrows. Again, because we're ignoring friction right now on purpose. The problem tells us this is hard enough without friction. Then it says apply Newton's second law to each axis independently. So that means do F net equals MA in the, like F net X equals MAX. That's one statement. And F net Y equals MAY. That's another, right? That's what that means. So in the x-axis, there's only one force. It's n sine theta equals, there's only n sine theta. So you'll literally say n sine theta equals MAX. But then you'll realize a x means the horizontal component of acceleration. Now, the block is actually accelerating on a diagonal, but your axes are x and y, right? So AX means A times cosine of the angle. I'm telling you, you'll want to explain that to me, but I'm saying your x-axis F net. I am giving you the answers here, but remember your job is to make sense out of all of this. But so you'll say n sine theta equals MA cosine theta on the x-axis. On the y-axis, you'll have Well, I would, sorry, and then one thing I left out, I would, since this thing is accelerating down, I would recommend, you can do whatever you want, but I recommend, and I sort of skipped this, somewhere in all of this, I would make it, in fact, I'm gonna tell you right now, I would go, I'm gonna try to change that diagram if I can remember. There's something a little bit off about this diagram that you're seeing in front of your page. One thing I don't like about this diagram that I gotta remember to change, or I'm telling you right now, for those people who are paying attention, it makes it look like positive X is to the right and positive Y is up. I think that's you can do that, but I think that's a bad decision. It's gonna make your life harder. The thing is going down and to the left. I would call left positive and I would call down positive. That's not a rule, but it's going to make your life a lot easier. And I didn't do this to throw you off. I sort of did it by accident and because you're allowed to do it this way. But I'm telling you right now, and I'll try to change it in your actual thing if I remember. But I would recommend calling left positive and calling down positive because that's the way the thing's going. So therefore, why am I saying all that? Like, and if you don't, and I am saying this now, so I have to hold you. If you don't, if you just follow that diagram, if you follow that diagram, you're allowed to. It's not wrong. But then what I just said a second ago, n sine theta equals ma cos theta, really, you'd have to technically say you'd have to technically say negative n sine theta, because the n is going in the opposite direction from what positive is if you accept that positive. Anyway, hopefully you follow. So similarly, on the y-axis, if we're calling down positive, which I do recommend, on the y-axis, I would say mg minus n cosine theta equals ma sine theta. Right? That's your y-axis statement. You can play the video again to get that again if you want, but I'm not making this up, right? Like if you were writing all this down and looking at your picture, you would see that I'm just taking the downward arrow and subtracting from it the upward arrow in order to analyze the y-axis. Okay, so that's what I would write down for 5. When it says apply Newton's second law to each axis independently, that's what it means. Okay, now 6, I'm not going to do this, but 6 is literally what some people in this class chose to do for an extra credit assignment at one point, and they got extra credit. But whether you did it or not, what it's asked, so now you have, but you got to do it here. So I'm going to give you the overview, and you can help each other, of course. I mean, it is just algebra, but the point is you now have 2 equations and you have 2 unknowns. The unknown that we're ultimately looking to solve for is A. We're looking to solve for the unknown called A. We're not going to get a number. We're going to get it as an expression of theta and G, right? But the problem is we have this other unknown called N. We don't know what the normal force is in magnitude. So we have 2 unknowns. That's annoying. We want to solve for A, but we have this other unknown N. However, luckily we have 2 equations. So you know in principle that's solvable. As long as you have an equation for every unknown, there's something you can do. Now, you could do whatever algebra you want, but it is solvable. I recommend that the way you do the algebra is you take each of the and this is a big physics recommendation in general. Again, this will come up in 204 in a different context. Take your 2 equations. Well, first of all, my recommendation is if you have a friend who did this for extra credit, go to them for help. But specifically, take the 2 equations that you've now written, the y-axis equation and the x-axis equation, and independently take each one and rearrange it until it's an expression, solve for n in each one. Like, just do every algebra that you need to do to set it up to make it an n equals blah, 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 blah thing. Now, in one of them, it's like one of them is n sine theta equals ma cosine theta. So you just like divide both sides by sine theta and you've got it. N equals ma cosine theta over sine theta. Fine. I mean, it looks annoying, but there it is. The other one stubs people a lot. My recommendation for the other one is collect all of the terms that have an n in them to one side of the equation, put all the rest of the stuff on the other side of the equation. So now you have a bunch of things on one side. You'll have like n sine theta, or wait, it actually isn't even that, because there's no friction here. Is it even that bad? It's not even that bad, but basically you collect any n terms by themselves and you get them by themselves. Like, so you'll have like, I mean, sorry, it's the same thing as what I just said a minute ago. You put the n terms by themselves on one side and then just factor out an n if there's more than one n term. If there's only one n term, and I guess there is only one in this, just divide both sides by whatever n is being multiplied by. So you get each expression, you get each equation as its own expression of n. And why do you do, in other words, the trick is you first solve for the thing you don't care about. In physics, you first solve for the thing you don't care about. You don't care about n, so you write each one in terms of n, and then set the two n's equal to each other. So the n's drop out. You have one long thing that's has a bunch of a's in it. Then you'll have to do the thing that I'm really recommending is, it'll look really annoying and messy, but just collect all the a terms together, get them all on one side, and then factor out an a and divide both sides by whatever that big parentheses is that you have. You'll have to think about this, and finally, I can give you one big hint or one big remind you of something from trig. Cosine squared theta plus sine squared theta, whatever theta is, always equals 1, right? You know this, and that's really just the Pythagorean theorem, just written for a unit, for a triangle of hypotenuse 1. Cosine squared theta plus sine squared theta equals 1, regardless of what theta is. You bear that in mind or write it down. You'll totally use that identity here. If you use that identity, you will find, after all the math, I am watching the time, after all the math, you'll find that a equals g sine theta. And you'll find that it was an annoying amount of work to get there. Like that's, I mean, like 6 is long. Be careful with 6 and explain as you're going 6. But by 7, you'll get, if you do it right, that a equals g sine theta. And the sort of the purpose of all this was to show you that it's doable, but annoying. Then here it asks you to plug in numbers for the various a's and show the trend of how it makes sense that a gets faster as the angle gets steeper. Okay, so so you're just going to plug in numbers there and show. Okay, now I can go a little, now we have 12 minutes left. On part 2, you're doing a comparison. You're basically going to do the whole same thing over again, but you're going to show the difference you're going to show where it's the same and different. So the first 3, I'm telling you right now, the first 3 better be the same answers as the other page. I mean, I'm just telling you because they have nothing to do with your core, because they're just true. Then 4 is where you now use the new coordinate system. So now you're lining up the x-axis with the acceleration. So now along one axis, your new thing that you call x-axis, you have mg sine theta. Oh yeah, and sorry, in all of the stuff I said above, you'll have m's in like a lot of your work, and that's fine. But when you finally get to the a, the m's will divide, like you'll see, they'll cancel out. So it's fine. Or you could, anyway, it's okay to have m's going along as long as they're not in the final answer. So same thing will happen here. You'll get on page 5, number 5 at the bottom, apply Newton's second law to each axis independently. You'll say mg sine theta equals ma along the plane. You'll say n minus mg cosine theta equals, oh, sorry, let me say that slow. Mg sine theta equals ma along the plane. Notice a is just a now. I mean, technically you're saying mg sine theta equals max along the plane, but all of a is now along x. That's the advantage of picking this new coordinate system where you've lined up the x-axis with a. So there is no components of a to take. That's a huge reason we're doing this. So mg sine theta equals ma, and on the other one, you'll say n minus, or you'll say mg cosine theta minus n equals ma y, like the acceleration along the y-axis, but you've chosen things here so that specifically the acceleration along the y-axis is 0. That's the point. So therefore, n just equals mg cosine theta here. And it's much more straightforward. So then mg sine theta equals ma, you divide both sides by m, boom, a equals g sine theta. Like the whole point is to show that when you tilt the coordinate system and break up gravity, oh, sorry, and I did skip something accidentally. I'll go back to it in a minute. But the whole point is that when you break up gravity, it seems like a weird thing to do, but we do it because we're allowed to and because it makes the math much easier. I should back up and say, I'm sorry, when you go to part 4, like of page 5, using the coordinate system specified, when you have to draw the component, do this. This is where, and I'm sorry I skipped this. This is where, again, in this piece, the problem, this is the issue. This is where you're going to show me that you're really in the class or not. Here, zoom in on gravity. Make a separate triangle of mg pointing down as a big hypotenuse of its own tilted right triangle, and divide mg into two components, like one that goes down and left and one that goes down and right, and put arrowheads on them and show that down left, tip to tail plus down right equals down. Like, that's counterintuitive. That's new understanding that we're getting from physics. But if you zoom in on that big triangle and show that this is mg and this is mg some component and this is mg the other component, and then you show by some logic that's similar to what I was yelling about 5 minutes ago, if you show that the angle in this triangle that matches the given angle of the original problem, that the theta is sort of at the top of this picture that I'm describing, so that it's opposite from the axis that's pointing along the plane, right? I think I just said that backwards. Sorry, which way am I doing it? Sorry, if you show that the angle is at the bottom, I mean, and that it's opposite from the component that's along the plane, then you can show that the component along the plane is sine theta. So first you zoom in on mg and over-explain this part. Again, this is like, I'm giving this walkthrough is, you might think, if you're listening right now, like, oh my God, he's giving away the whole exam. Like, how? Like, I've been working this entire semester, like he's giving the whole exam to, believe me, okay, I'm partly helping people that still are looking for a fighting chance in this class because everybody deserves one, yes. But if you haven't been paying attention all semester, this is a lot to absorb right now. I know that. And if you're not even paying attention now, or you're not here right now, it's irrelevant to absorb. I'm telling you all who are paying attention right now, believe me, I know from experience, even with this whole walkthrough, and I don't mean that, I mean this respectfully, there's still a lot of people that still won't do what I'm saying. I mean, for whatever reasons, that might be super legitimate. There's still a lot of people in this room that won't get the fundamentals of this for whatever reason. But I'm also saying, if you're one of the people that is paying attention right now and thinking that I'm giving away the farm or that I'm almost undercutting the work that you've been doing the entire semester, then what you're listening for is the pro tips, okay? And the pro tips are where it's like the game of where you can separate yourself from someone who just has the basics for someone who really knows what I'm really looking for. And what I'm really looking for is in the normal force case up above, really explain why the horizontal thing is sine rather than cosine. That is a surprise that someone who's really wrestling with this material can show me in their exam. And similarly here, show me on this part where I'm right now, where am I? On this part that I am right now, page 5, Roman numeral 4, if you can really show me with separate diagrams that have tips and tails and everything clear, show me why mg sine theta is the thing along the plane. That's the pro tip right there. Okay, I mean, because it's harder to do than it sounds. We have 5 minutes left. I'll also say, by the way, to everybody, I reserve the right. If I could absolutely give you this exact same exam, but with the original diagram, I'm not saying I'm going to do this, but like, just so you understand, like, I could put theta, I could give that original diagram that you're looking at right now, but have theta be drawn up at the top rather than the bottom. And then you'd have to switch everything accordingly with that. You'd have to show that you really get the logic, that you haven't just memorized a bunch of components. I mean, I've done that. Am I saying I'm going to do that? Like, probably not, but that's a kind of thing that would just be one small adjustment that would totally separate those people who right now I'm reviewing for versus those people that are learning this from the first time. And I don't mean that insultingly, like, life happens, but okay. So just like, no, if you're really trying to practice or really see if you can do this whole problem, like if you get it, even if I were to give the original theta as up at the top rather than at the bottom, anyway, all right, I know we have 4 minutes left. So, you find here in part 7, you'll do mg sine theta equals ma. Cross out the mg of g sine theta equals a. You're done. There's no crazy math to do, and that's like the whole point, okay? Then you plug in the numbers again here. It asks you to plug in the numbers and show. I'm not going to walk through this now. You can do that, but you should find that the normal force gets weaker and weaker as the angle gets bigger and bigger. If you don't find that, something's wrong. Okay, so see, I'm not going to give this away. Right. Okay. I know we have only 4 minutes. C and D is when you're like really trying to show the big picture of why you just went through all of this. I feel like I keep saying it. I'm not going to say it again right now because I'm not trying to be rude, but just in the sake of time, like this is all like you should expect the two answers to be the same. But the whole method is this is all about. Yeah, I'm not going to. This is all about Galileo's principle. It's all about the laws of physics are the same in all unaccelerated coordinate systems. Like that's the whole point of all. But why we care so much? It's all about that the Earth is moving at 65,000 miles an hour, and yet we don't feel it. And that means we can choose to do physics from any perspective we want, and we should choose to do it from perspectives that make the math easier. Okay, now, because I know we only have 3 minutes, then E, now I have to, okay, I know I have to do this quickly, and I apologize. It is what it is. Here now, in the last part, now it gets into the friction and the lab. I will, like, a lot of this stuff will still be the same. First of all, I would recommend, now that you've just gone through all that, now that we're going to add friction, stick with the coordinate system that made the math easier. Stick with the tilted coordinate system to do the rest of this. And now you're just going to add a friction term to the coordinate system. Friction should always be going the opposite direction. I'm giving big picture now. Should always be going in the opposite direction of whatever the motion is of the object. And friction is mu times the normal, right? And the normal here you solve for by doing the components. Okay, I'm just going to summarize. If you walk through this carefully and you actually just add friction in along the plane and make it go opposite to the direction of wherever the object is going, and you realize that friction is mu times the normal, ultimately you absolutely should find that the time elapsed to go up the plane is less than the time to go down. Like that is the lab finding. That's the point of this whole thing. For one moment, you should find that surprising. That is surprising. That's why this is an exam. That's why this is like the whole physics unit. But it is the case. And your job is to show why. The time up should be smaller than the time down. And the reason is that on the way up, both forces are working together. But on the way down, they're in conflict with each other. I mean, that's the overall summary of this whole of C on that page. Now, we have 1 minute left. The last page, like it has to do with the MGH, which was what we've been doing for the last week. This also will separate the wheat from the chaff. It's not meant to be hard. It's meant for you to know about how MGH relates to 1F MV squared, the stuff that we were doing the last week. The last two questions, H and I, to be super honest, that's what I was going to explain all today, but I didn't. I don't know what I'm going to do about that. I'm aware that I will not have explained it now.
May I possibly suggest that maybe on Google Classroom you put the link to when you maybe have explained this in a past semester?
That is actually
Possibly.
okay. That was a shockingly good suggestion for something so. I was so okay. Yeah, that's a very good suggestion. Thank you. And it was very risky, by the way. Yes. Okay. I will probably do something like that, or I'll make these. I will do something helpful, and I will because we do need. It's not meant to be hard. They're meant to be plugins, but it's stuff that we need to enter 204. So I'll do something probably like what Katie said, or some other way of being compassionate and recognizing that I didn't get to talk about them today. Yeah, but that's a good idea. All right. Anyway, it is 1:30. So thank you for that. That's actually a very helpful suggestion. But I'll be aware that I didn't talk about them. But and obviously the most of the whole exam I just walked through. So hopefully that will help you guys a lot. Also, it is an exam. So if you have to do some thinking on your own, that might not be the craziest thing. But okay. So it's 1:30. I hope that helped a little bit. I hope to see you guys or stay in contact. I wish you very, very well. You've been a great group. I also wish you great holidays. I will hang out for a minute or two for any last questions today, and I will be available by text or email, etc. So Quark bless America. I'm going to stop the recording, but I'm going to stay here for a minute. But thank you guys very much. Okay. And I'm going to yes, have a great day. Also, I'm going to turn off. Hold on a second. Yes, okay.
So,
You,
Professor, I was able to fix it. What I did was I exited out of the classroom and I rebooted the classroom to see if that would reload the page, and it did reload the page.
oh,
So I think maybe it's just a glitch in the system because it kept saying that it was loading even though it was already on the screen.